anyone tell it? Directly जर आपण FM directly if we are giving the FM demodulate FM signal to the demodulator, are we able to get directly the modulating signal at output? Directly modulating signal मिळतो का आपल्याला आउटपुटला FM detector मध्ये? So what are the steps, basic steps involved in that? At least tell me the steps. In detail I will not ask. In which two steps the FM demodulation takes place? First, काय होतं त्याचं? FM चं कन्वर्जन कशामध्ये होतं औदुंबर?
फ्रिक्वेन्सी सिलेक्ट होते AM डिटेक्टर.
FM आपण FM आपण फ्रिक्वेन्सी सिलेक्टरला देतो आणि फ्रिक्वेन्सी सिलेक्टर it is one circuit which is generating equivalent voltage in proportionate with input frequency. So input frequency च्या proportionate मध्ये याच्यामध्ये output voltage generate होतं. So whatever is the FM that is converted into equivalent AM signal form. आणि मग जो जनरेट झालेला आहे AM signal तो आपण पुढे AM detectorला देतो and through that AM detector we are able to recover our original modulating signal that we have seen. Basic working principle. Here is the block diagram. FM selector, here we get AM, then it is given to AM detector and at the output we are able to get the modulating signal. Then this is the circuit diagram for the slope detector. 4 types detector आपल्याला FM मध्ये स्टडी करायचे. So 4 types of detectors are there. So this may be asked as an oral question. Which are the circuits used for FM detector? So first one it is the slope detector. First circuit it is slope detector. So here is the circuit. ह्या ब्लॉक डायग्राम वरूनच हे सर्किट तयार झालेलं आहे. So frequency selector it is nothing but a tuning circuit. So you can see here with these dotted lines. So this one it is the tuning circuit and output of frequency selector is given to AM detector. So whatever is this diode and this RC filter, this is forming the AM detector circuit. So AM detector is recovering the original modulating signal. Slope detector हे basic circuit आहे. Then what is drawback of this slope detector? What is expected here that maximum frequency of FM should give maximum amplitude of AM. Minimum frequency of FM should give the minimum amplitude of AM. That is quite natural expectation here. But still, that is practically not happening. Some amount of error it is occurring there. That error it is called as the slope error. So to avoid that error or to overcome that error, we are using some modified type of slope detector which is known as the balanced slope detector, or another name for that is also dual slope detector. So what happens in dual slope detector? Basic circuit is same, but instead of one frequency selector and one detector, in balanced slope detector we are using 2 frequency selector circuits and 2 AM detector circuits. Okay, so that is the working principle and main difference here. ट्रान्सफॉर्मरला सेंटर टॅप करून त्याचं जे अप्पर वाइंडिंग आहे that is tuned with the frequency FC plus del F. Whatever is this lower winding that is tuned with the frequency FC minus del F, and whatever is this input tuning circuit that is tuned with the carrier frequency. So when input FM, इथे input FM सिग्नल देतो आपण, ह्या FM सिग्नलची फ्रिक्वेन्सी जेव्हा कॅरियर एवढी असते, at that time it is this circuit it is tuned, so these two will not come in picture and output voltage will be 0. जेव्हा इनपुट सिग्नलची फ्रिक्वेन्सी कॅरियर पेक्षा जास्त असते तेव्हा कुठलं सर्किट ट्यून होईल त्या केस मध्ये? T1 मधलं का T2 मधलं सांगा? When input frequency here, yes, T1 or T2, Audumbar, it was not audible. Can you repeat? T1. As it is tuned with the frequency greater than carrier, हे सर्किट ट्यून होतं. मग हे ट्यून झाल्यामुळं डायोड D1 is forward bias and D2 will reverse bias. So voltage at the output of diode D1 is given by V1. D2 च्या output voltage आहे V2. So in this case the V1 is greater than V2 and output voltage we are getting positive. म्हणजे जेव्हा कॅरियर फ्रिक्वेन्सी पेक्षा इथली फ्रिक्वेन्सी जास्त असते तेव्हा आपल्याला पॉझिटिव्ह व्होल्टेज. And when the input signal frequency is less than carrier, at that time this circuit is tuned and this V1 is less as compared with V2 and we get the negative voltage at the output. म्हणजे थोडक्यात आउटपुटला जे V0 फायनल आउटपुट व्होल्टेज मिळतात हे जे फायनल व्होल्टेज V0 मिळते आपल्याला that is in proportionate with this input signal frequency. This is the working principle of this slope detector or balanced slope detector, or it is also known by the name as dual slope detector. So here the slope error it is removed and the accuracy of the signal or the efficiency of the signal it is more as compared with the basic slope detector. That is the concept we have to remember here. हे झाले दोन टाइपचे स्लोप डिटेक्टर. पहिला झाला आपला रेग्युलर स्लोप डिटेक्टर and second one it is known by the name as balanced slope detector, or it is also known by the name as dual slope detector. Okay, then the third type of detector we have seen. So what is that third type of detector? Can anyone tell? तिसरा टाइपचा कुठला डिटेक्टर आपण बघितलेला लास्ट लेक्चरला? What is this third type of detector? That is Foster-Cini discriminator, or it is also known by the name as Foster-Cini detector. Okay, so what happens in that Foster-Cini detector? That I will just show. Just a minute. So for this specific point, I am going to add these particular sites also. So whatever is this site, that I will add as additional material in your study material. Additional notes मध्ये किंवा class notes च्या row मध्ये this particular links I will add today so that it will be helpful for you to study. हे दोन पॉइंट आपल्या ह्या नोट्स मध्ये नाही आहेत, क्लास नोट्स जे आहेत त्याच्यामध्ये हे लास्टचे दोन पॉइंट नाही आहेत. So for that two points specifically, whatever are these links that I will provide in your study material. So Foster-Cini discriminator मध्ये काय आहे? So basic circuit it is same. So if you see, I will repeat it once again. Foster-Cini discriminator. Here is the primary of the transformer. Here it is the secondary. Secondary ला center tap केलेला आहे. Basic circuit is same as that of the dual slope detector. Only here additionally this choke it is added. So function of the choke it is, if in the output if some amount of RF signal components are present किंवा काही जास्त फ्रिक्वेन्सीचे कंपोनंट जर अजून आउटपुट मध्ये प्रेझेंट असतील तर that is removed with the help of this RF choke. Okay, so that is the additional function. So in many respects the Foster-Cini demodulator resembles the circuit of a full wave bridge rectifier. The format uses the center tap transformer. It is used here, and additional components are added to give a frequency sensitive aspect. माझा हा additional component आहे, that is nothing but this RF choke. So what is function of this RF choke? आउटपुट ला जनरेट झालेल्या सिग्नल मध्ये जर अजून काही हाय फ्रिक्वेन्सी कंपोनंट म्हणजे RF कंपोनंट्स प्रेझेंट असतील तर टू रिमूव्ह दॅट RF कंपोनंट्स दिस RF choke it is used. Okay, so the basic operation of circuit can be explained by looking at the instances when the instantaneous input equals to the carrier frequency. जेव्हा हे इनपुट सिग्नल कॅरियर फ्रिक्वेन्सी एवढा असतो तेव्हा ह्या दोन्ही ट्रान्सफॉर्मरचं आउटपुट means same voltage is produced here. So final output voltage is 0. If the frequency of the input changes, the balance between the two half parts of this transformer secondary changes and the result voltage is proportionate. म्हणजे जसं आपण इकडे बघितलं की समजा इनपुट फ्रिक्वेन्सी कॅरियर एवढी असेल तर आउटपुट व्होल्टेज 0 असतं. Suppose input frequency is higher than carrier frequency, D1 will become forward bias. This output voltage will be again positive. If input frequency is less than carrier, this D1 will become reverse bias, D2 will become forward bias, and त्या केस मध्ये आउटपुट व्होल्टेज आपलं negative. So same working principle it is used here. Just the additional thing we have to consider here. ड्युअल स्लोप डिटेक्टर आणि फोस्टर सिली डिस्क्रिमिनेटर मध्ये ह्याच्यामध्ये मेन डिफरन्स काय आहे की दिस सर्किट इज मोर फ्रिक्वेन्सी सिलेक्टिव्ह बिकॉज ऑफ यूज ऑफ दिस ॲडिशनल RF choke which is eliminating the high frequency signals. If still some high frequency signals are present in the output, then those are eliminated by this RF choke. That is the principle of this Foster Cili discriminator. Okay, so it is also used for the frequency control in some of the applications. So this diagram is only expected for this Foster Cili discriminator. Now we will see the last type of the detector, that is ratio detector. Okay, so we will see this ratio detector. So this is the circuit used for ratio detector. आता सगळीकडे लास्ट 3 टाइपचे आहेत डिटेक्टरचे, म्हणजे ड्युअल स्लोप डिटेक्टर, फोस्टर सिली डिस्क्रिमिनेटर आणि रेशो डिटेक्टर. एव्हरीवेअर ऑलमोस्ट बेसिक वर्किंग प्रिन्सिपल इज सेम की 3 ट्युनिंग सर्किट आहेत तिथं. एक ट्युनिंग सर्किट कॅरियर फ्रिक्वेन्सीला ट्यून केलंय, दुसरं ट्यून केलंय FC प्लस डेल एफ ला आणि तिसरं ट्यून केलंय FC मायनस डेल एफ ला. सो इन दॅट केस जेव्हा इनपुट फ्रिक्वेन्सी कॅरियर एवढी असेल इथं सुद्धा सेम तेच होणार आहे. ओनली व्हॉट इज द डिफरन्स? सो आय विल जस्ट रीड. इन फोस्टर सिली डिस्क्रिमिनेटर द amplitude of resulting output voltage is varying as per the input signal, and the whatever is the discriminator circuit is modified to provide the amplitude limiting of the incoming signal, and it is termed as the ratio detector. So ratio detector and Foster Cili discriminator are almost same. Only 2-3 changes are there in the circuit, and then it is converted in the form of रेशो डिटेक्टर. म्हणजे फोस्टर सिली डिस्क्रिमिनेटर मध्ये आपण स्लाइटली काही चेंजेस केले तर देन इट इज कन्वर्टेड इन द फॉर्म ऑफ रेशो डिटेक्टर. सो सेम इट इज गिवन हियर. द रेशो डिटेक्टर सर्किट इज गिवन as in the figure 1. So ratio detector circuit is almost same as Foster Cili discriminator except for the below modifications. So only few modifications are there in the ratio detector circuit. So what is the first modification? See here, diode D2 is in the reverse condition. म्हणजे जर आपण आता इथे फोस्टर सिलीचं सर्किट बघितलं तर see this circuit and ratio detector circuit, if you compare, only what is the first change? रेशो डिटेक्टर मध्ये हा D2 डायोड जो आहे that is kept in the reverse position. Okay, so the first change in the ratio detector is diode D2, it is in reverse condition. Then second change is a large capacitor C9 is connected across the output voltage of the two diodes. जे काही हे फायनल आउटपुट आहे or after this R2 and R3. So if you compare this diagram, इथं R1 R2 च्या अक्रॉस आपल्याला आउटपुट मिळतंय, पण ह्या रेशो डिटेक्टर मध्ये काय आहे की इथं C9 C5 C6 R1 R2 याच्यामध्ये 2 पॉइंट घेतलेले आहेत P आणि Q, आणि ह्या P आणि Q च्या आउटपुटला आपल्याला फायनल आउटपुट मिळतंय. अँड व्हेअर एज फोस्टर सिली मध्ये जिथं आपल्याला फायनली आउटपुट मिळत होतं त्याच्याऐवजी इथं काय प्लेस केलेलं आहे कॅपॅसिटर C9 हॅव्हिंग व्हेरी हाय व्हॅल्यू इट इज प्लेस. सो दॅट इज द डिफरन्स. सो सेम इट इज गिवन हियर. अ लार्ज कॅपॅसिटर C9 is connected across the output voltage of the two diodes. हे आउटपुटला इथं C9 कॅपॅसिटर कनेक्ट केलेला आहे. Then next difference is the output voltage of the detector is taken across P and Q. So final output voltage is taken across these points P and Q. Then the primary and secondary circuits are tuned to carrier frequency, and C3 is the coupling capacitor while L3 is the RFC element. So here also the choke it is used, and additionally this C3 capacitor it is used here. Okay, that is the coupling capacitor. The two generated frequency dependent output voltages are applied to the two diodes D1 and D2. So again it will be same. Input carrier एवढं असतं तेव्हा output is 0. When input is greater than carrier, this D1 will become forward bias. And here whatever is the value of VO1, that will be greater than the value of VO2. पण इथं हे जे काही voltageच्या व्हॅल्यू आहेत, that voltage values are stored in this capacitor as it is having very high value. म्हणजे याच्यामध्ये काय होतं, फायनली आउटपुट व्होल्टेज कॉन्स्टंट राहतं. Though the values of VO1 and VO2 are changing, whatever is the final Vout voltage, that Vout voltage remains constant. आणि ह्या दोन्ही मधला रेशो फक्त चेंज होतो. ओके, सो सेम पॉइंट इट इज गिवन हियर. I will just read. The two generated frequency dependent output voltages are applied to the two diodes D1 and D2. The capacitor C9 has large value, typically 10 microfarad, which are the peak value of the L2, and due to charge time constant, it holds this of this V2 and Vout, that is hold across this capacitor value. Because of the value of capacitor, the effect of any output variations due to noise and other interference is minimal on the charge of the capacitor C9, and the voltage remains constant. C9 ची व्हॅल्यू ह्या सगळ्या व्होल्टेजच्या कंपॅरिझन मध्ये खूप जास्त असल्यामुळे C9 च्या अक्रॉसचं व्होल्टेज कॉन्स्टंट राहतं. Additional limiter circuit is not required since the output voltage is not affected by the amplitude variations in the incoming signal. So because of that, the additional limiter circuit it is not required. Then conversely, when D1 conducts more than D2, जेव्हा D1 जास्त म्हणजे ही जेव्हा फ्रिक्वेन्सी FC पेक्षा जास्त असेल तेव्हा D1 जास्त कंडक्ट होतो. So when D1 conducts more than D2, VO1 exceeds VO2. हा जर कंडक्ट झाला तर ऑब्विसली VO1 ची व्हॅल्यू ही VO2 पेक्षा जास्त असते. That's why VO1 exceeds VO2, again resulting in the sum of these voltages as constant. So though the values of VO1 and VO2 are changing, because of high value of this capacitor, हे जे Vout चं व्होल्टेज आहे ते कॅपॅसिटरच्या अक्रॉस स्टोअर झालेलं असतं. त्यामुळे VO1 VO2 जरी चेंज झाले तरी आउटपुट व्होल्टेज चेंज होत नाही. Thus the output voltage Vout is negative. Therefore in this circuit the sum of the voltages VO1 and VO2 always remains constant, but their ratio changes depending on the signal frequency, and hence this circuit it is called as the ratio detector. Okay, so here the main difference is फोस्टर सिली डिस्क्रिमिनेटर मध्ये काय केलं होतं आपण, R1 R2 च्या अक्रॉस फायनल आउटपुट घेतलं होतं. बट इन रेशो डिटेक्टर वेअर द फायनल आउटपुट इज टेकन, इट इज टेकन इन बिटवीन दिस सेंट्रल पॉइंट्स P and Q. मग हे C5 C6 R1 R2 च्या मध्ये हे पॉइंट्स आहेत, त्याच्या अक्रॉस आपण फायनल व्होल्टेज घेतो. सो वॉट एव्हर इज दिस फायनल Vout व्होल्टेज, दिस व्होल्टेज इट इज स्टोर्ड अक्रॉस दिस कॅपॅसिटर, आणि हा कॅपॅसिटर हाय व्हॅल्यूचा असल्यामुळं Vout ची व्हॅल्यू C9 च्या अक्रॉस स्टोर होते. अँड ॲज दिस C9 व्हॅल्यू इट इज व्हेरी हाय, त्याच्या कंपॅरिझननी VO1 VO2 च्या व्हॅल्यूज खूप कमी आहेत. त्यामुळे जरी ह्या व्हॅल्यूज कमी जास्त झाले VO1 VO2, फायनल Vout व्होल्टेज हे कॉन्स्टंट राहतं. फक्त VO1 आणि VO2 ह्याच्यामधला रेशो चेंज होतो. दॅट्स वाय there is no need of additional limiter to be used in this circuit, and as the ratio between this VO1 and VO2 is changing, this is called as the ratio detector. So this is the fourth type of this FM detector, which is known by the name as ratio detector. And out of this four, the ratio detector, it is giving the better performance. Okay, so slope detectorचा कमी असतो, याच्या कंपॅरिझनने बॅलन्स स्लोप डिटेक्टरचा परफॉर्मन्स इम्प्रूव्ह होतो. As compared to this, booster ceiling discriminator is giving better performance. And if you compare again this four, ह्याच्यापेक्षा ह्याच्यामध्ये रेशो डिटेक्टर मध्ये लिमिटिंग सर्किटची गरज पडत नाही किंवा फायनल आउटपुट व्होल्टेज कॉन्स्टंट राहतं C9 यूज केल्यामुळे. So if you compare these four, this ratio detector, it is giving the better performance. Okay, so these are the FM detector types that we have studied in our syllabus. मग कुठलेही आपण बघितले तरी बेसिक तेवढा सेम कन्सेप्ट आहे. ट्युनिंग सर्किट कुठल्या फ्रिक्वेन्सीला ट्यून केलेले असतात, दॅट यू हॅव टू रिमेंबर carrier frequency or greater than carrier frequency or less than carrier frequency. So based on these tuning circuits, the performance it is increased. And most, if you compare this four ratio detector, it is giving the proper or better performance out of this four. So this is all about this chapter number 5. So if you have to revise what we have seen, so we have seen first this two terms, modulation index, त्याचे दोन इक्वेशन बघितले, डेल डिवाइडेड बाय FM. डेल म्हणजे फ्रिक्वेन्सी डेविएशन, which is given by two equations, F max minus FC or FC minus F minimum. So this is the standard formula for modulation index. Then we have seen the derivation for FM. FM derivation, it is complicated. So हे फायनल इक्वेशन आहे FM चं. ह्याच्यामध्ये काय आहे, दिस टर्म कन्सिस्ट ऑफ साइन ऑफ साइन. साइनचं साइन ही टर्म ह्याच्यामध्ये प्रेझेंट आहे. दॅट्स वाय दिस इक्वेशन इट इज कॉम्प्लेक्स अँड इट इज नॉट इझी टू ड्रॉ द फ्रिक्वेन्सी स्पेक्ट्रम ऑफ FM. सो व्हॉट वी हॅव डन टू ड्रॉ द फ्रिक्वेन्सी स्पेक्ट्रम ऑफ FM. FMच्या फ्रिक्वेन्सी स्पेक्ट्रम मध्ये फ्रिक्वेन्सी कशी चेंज होते सांगा. How the frequency changes in frequency spectrum of FM? Central ला कुठली frequency असते? Which frequency is there at center in FM frequency spectrum? Which frequency is there at the center in FM?
VC
or FC. Carrier frequency. Correct. Voltage पण आपण कुठलं घेतो तिथं, कॅरियरचं. If you go right hand side, every time it is increased by the value of modulating signals frequency. So central FC आहे, right hand side ला it is FC plus FM, FC plus twice FM, FC plus thrice FM. That is there for right hand side. Left hand side ला काय होतं, it is FC minus FM, FC minus twice FM, FC minus thrice FM. Like that it will change. हे झालं फ्रिक्वेन्सीचं. आणि व्होल्टेजसाठी काय केलेलं आहे आपण, बेसल्स फंक्शन चार्ट यूज केलाय. फॉर डिफरंट व्हॅल्यूज ऑफ मॉड्युलेशन इंडेक्स, द नंबर ऑफ साइड बँड्स प्रेझेंट इन द FM आर डिफरंट. Okay, so these are the different frequency spectrums for different values of modulation index. Then we have seen the equation for bandwidth of FM. AM मध्ये bandwidth चे equation आहे twice of FM, whereas in frequency modulation circuit the bandwidth equation it is critical. So as per the Carson's rule, how the bandwidth we are calculating, what is the equation for bandwidth? 2 in bracket del max plus FM max, म्हणजे maximum frequency deviation plus maximum modulating signal ची frequency. That is the Carson's rule for bandwidth equation. मग दोन टाइप बघितले आपण FM चे, नॅरो बँड FM सिग्नल आणि वाईड बँड FM सिग्नल. नॅरो बँड FM सिग्नलच्या आउटपुटला आपल्याला कमी मिळते बँडविड्थ आणि वाईड बँड FM सिग्नलच्या आउटपुटला we are getting the wide range at the output of this FM signal. Okay, for this wideband FM. So here the bandwidth of system is less, modulating signal frequency कमी आहे, frequency deviation ची value कमी आहे, modulation index is approximately 1. In wideband FM signal, modulation index is also more. Modulating signal frequency and deviation ह्या दोन्ही व्हॅल्यू याच्यामध्ये जास्त आहेत. That is the difference between two. Then we have seen the FM generation methods, direct method and indirect method. So in case of direct method, reactance modulator use करून FM generate केला जातो. This is with reactance modulator by using the FET device. We have seen the reactance modulator. Then in indirect method, Armstrong method, it is frequently used for FM generation. Then we have seen these two processes in FM, pre-emphasis and de-emphasis. So why these two processes are carried out? Can you tell? Why these two processes are carried out in FM, pre-emphasis and de-emphasis? Can you tell? What is the basic intention for carrying out these processes? Why these two processes are carried out in FM? Pre-emphasis, de-emphasis. Yes? Audubon, can you tell?
boosting high frequency signal.
हायर फ्रिक्वेन्सी सिग्नल ट्रान्समिट करायच्या आधीच आपण त्याला बूस्ट करतो. दिस इज टू अवॉइड द इफेक्ट ऑफ द नॉईज. नॉईजचा जो इफेक्ट आहे FM मध्ये तो इफेक्ट कमी करण्यासाठी आपण प्री एम्फासिस प्रोसेस यूज करतो. ओके. देन प्री एम्फासिस इज डन ॲट ट्रान्समीटर, डी एम्फासिस इज डन ॲट द receiver side. Okay. Then we have seen this FM detector, slope detector, balanced slope detector, Foster Celia discriminator and ratio detector. So these 4 FM detectors we have seen. So here we are completing the chapter number 5. So we will discuss the assignment questions and MCQs for this chapter. And today at 4 p.m. I will provide you the MCQ link or MCQ test link for chapter number 4. So your 4th chapter ची तुमची MCQ ची टेस्ट राहिलेली आहे. तर ती टेस्ट आपण आज घेऊया. ॲज आय हॅड पुट मेसेज ऑन युअर ग्रुप येस्टरडे. आणि तुमची जी 5व्या चॅप्टरची राहते टेस्ट ती तुमच्या ISC च्या दिवशी घ्यायची का? AC च्या ISC च्या दिवशी आहे त्या दिवशी. बिकॉज आय डोंट नो वेदर हिअर आफ्टर लेक्चर्स विल बी देअर ऑर नॉट. Here we are completing the syllabus, so we will discuss. हाँ आज काय?
M3 ची टेस्ट आहे मॅम 4च्या नंतर.
कोणाची?
हंडे मॅमची.
हंडे मॅडमची. So yesterday only I had put message on your group. No, I have not mentioned actually timing because I didn't think that की 4 नंतर असेल कोणाची म्हणून. मॅडम किती वाजता पाठवणार आहे टेस्ट? किती वाजता पाठवणार आहेत?
4:30 पर्यंत पाठवते म्हणलं.
बरं ठीक आहे. असो यू टेक मोर टाइम फॉर दॅट ना.
4:30 मॅम.
हां 4:30 वाजता M3 ची आहे ना. सो आय विल सेंड दिस ॲट 5:30 PM. यू सबमिट इट अप टू 7:30. आय विल नॉट मेन्शन टाइम इन युअर ग्रुप. 2 तासात तर सबमिट करू शकता MCQ सॉल्व करून.
Yes ma'am.
So this
Yes, ma'am, no problem.
unofficially I am
No problem.
telling. I will not put any message on your group about timing. I will send the link at 5:30. You submit it up to 7:30. Okay. So that there will not be any burden to you. आणि ISC आपली आहे त्या दिवशी 5व्या चॅप्टरची MCQ टेस्ट आपण घेऊया. सो दॅट तुमचा स्टडी पण झालेला असतं त्यावेळेस. And at that time only we will take this online test for chapter number 5. Okay. So syllabus for second ISC, it will be your chapter number 4 and 5, second section. Okay, सहावा चॅप्टर आता तुमचा सिलेबस मधला रिड्यूस केलेला आहे. So there will be chapter 4 and 5 for your ISC 2. So related to that, if you have any doubt, you can ask. ISC चा पॅटर्न तुमचा सेमच असेल. जसं पहिले 6 क्वेश्चन्स MCQ चे आहेत आणि पुढचे असतील ते तुमचे theoretical questions असतील. And additional MCQ links are there with me based on chapter number 3 and 4. जर तुमचे ISC नंतर लेक्चर होणार आहे म्हणून सांगितलेत का सीसीने काही इन्स्ट्रक्शन्स दिलेत का तुम्हाला? कारण उद्यापासून ISC आहे ना तुमची.
अजून काय नाही सांगितलं.
अजून नाही सांगितलं. ओके. सो वी विल सी. जर अजून काही लेक्चर झाले तर आपण त्याच्यामध्ये ॲडिशनल MCQ ची प्रॅक्टिस करूया. Additional MCQs we will discuss. So some MCQs are with me which I have taken from internet related to modulation. That links also I will provide in your study material. You can study it by your own, and if we get more lectures we will discuss related to MCQs. Okay. आणि मग जर रिव्हिजनचे लेक्चर मिळाले तर कुठला पॉईंट तुम्हाला समजला नसेल किंवा रिपीट करायचा असेल तर त्यावेळेस मला सांगा. That point we can cover. Okay. So is there any issue related to study material or notes or what? If you any issue, you can tell me after this discussion. Okay. So we will see this assignment questions and MCQ first for this chapter. So first question is explain the working principle of ratio detector. So just now we have seen that diagram and its explanation you have to write in that. Then second, write an expression for FM modulated wave. FM चे डेरिवेशन लिहायचे ह्याच्या आन्सर मध्ये. And next part is what is narrow band and wide band FM signal. So what is the concept of this narrow band and wide band FM signal that you are supposed to write. Okay. So narrow band FM signal, wide band FM signal we have seen. Same explanation you write here. Then explain principle of FM wave generation using direct method. State merits and demerits of this method. So you are not supposed to explain here merits and demerits. Only just write the FM generation method by using the direct method. The reactance modulator आहे. That diagram you can draw and you can write down the answer for this. Then yes, another part is there. General question that is asked usually. Compare AM, FM and PM. Okay, so if you have to compare that 3 types of modulation, you will get the different parameters for comparison. आता इथे FM application आहेत पण ते आता that is just general question I have added in the assignment. You can search on net what are the different applications of FM and that you can write down. And one more question it is asked here. Compare AM and FM. So which parameters you can get for this comparison? You tell me. कुठले comparison चे points असतील AM आणि FM साठी? सांगा मला कुठले comparison points असतील AM FM साठी? First is basic working principle. So here if you see comparison like this, बघा आता इथं दिसतंय तुम्हाला comparison table. Compare between FM and AM. Okay. So FM मध्ये काय होतं? Amplitude constant असतं. इथं AM मध्ये amplitude change होतं. In FM frequency is changing, amplitude is constant. In AM amplitude is changing, frequency is constant. Okay, so like that different comparison parameters are there. What is the bandwidth formula? What is the complexity? What is the what we can say noise immunity? FM receivers are more immune to the noise. म्हणजे noise ला oppose करायची efficiency FM ची जास्त आहे, whereas in case of AM it is less immune to the noise. So like this, all that things you can write here in the comparison. Okay. So That was one question in the assignment, comparison between AM and FM. Then next is explain the Armstrong method to convert phase modulation to frequency modulation. So Armstrong method, that is the indirect method for FM generation. So there you can convert the narrowband FM signal into wideband FM signal with the help of this phase modulator. So that diagram you have to try and write down the explanation. This question is repeated. Ratio detector distinguish between narrowband FM and wideband FM signal. The parameters आहेत comparison चे. Modulating index, then modulating signals frequency, deviation, त्या सगळ्या values तुम्ही तिथं comparison मध्ये लिहू शकता. Okay? And then next it is compare explain the ratio detector, that is actually repeated. Instead of this you can take the Foster-Seeley discriminator. So Foster-Seeley discriminator you can write instead of this ratio detector again. And one more question, it is not here, that just I will add, that is explain the, okay, here it is there, sorry, I didn't see it here. आहे इथं already Foster-Seeley discriminator चा question. Then explain the need of pre-emphasis, de-emphasis. And here you can write instead of this Foster-Seeley discriminator, explain the slope detector circuit. Slope detector, balance slope detector, that circuits you can write here. Okay, so these are the assignment questions. MCQs we will see. So you see these MCQs carefully and give the answers. First question is, what is role of amplitude limiter in FM receiver? FM receiver मध्ये amplitude limiter एक circuit use केलेलं असतं. So what is use of that amplitude limiter circuit in FM receiver, that is asked. So first is filtration, second adjust the gain of the receiver, amplify the weaker signal, and fourth it is demodulate a signal. So this is somewhat different question, so I will tell the answer. Amplitude limiter चं function असतं to demodulate the signal. That is basic function of this amplitude limiter in the FM receiver. So option D is correct for this particular question. Amplitude limiter चं function आहे to demodulate the signal. Okay. Then next question is, what is carrier swing? So what is the meaning of this word carrier swing? So first is frequency deviation, B width of sideband, C instantaneous frequency, and D is total variation in the frequency. So can you tell what is the meaning of the carrier swing in FM demodulation or FM modulation? Carrier swing means, yes, at least try to give the answer. Carrier swing means what? Can you tell answer? Carrier swing, it is the similar word as that of frequency deviation, or it is the total change in the frequency. किती त्या carrierच्या frequency मध्ये change होतो, that is called as the carrier swing. So if you search on the internet, you will also get the answer. Carrier swing is the total variation in the frequency. Frequency मध्ये total किती change होतो, that is the meaning of this carrier swing. Then next question is, the amount of data transmitted for a given amount of time is called as. एका specific time मध्ये जो काही data आपण transmit करतो, that is called as, it is asked, that is called as the bandwidth. एखाद्या specific time मध्ये जो data आपण transmit करतो, that is called as the bandwidth. Okay. Amount of data transmitted for given amount of time is called as the bandwidth. Then next, you now give answer for the question. Function of frequency mixer in super heterodyne receiver is. What is the function of mixer in super heterodyne receiver? Amplification. Amplification होतं का super heterodyne receiver मध्ये, mixer मध्ये? Second is filtering. C. Multiplication of incoming signal and the locally generated carrier. And D, it is none of above. So what is the function of frequency mixer in super heterodyne receiver? What is the function of this frequency mixer in super heterodyne receiver? Give the answer. It is very simple. Shivani. What is the function of frequency mixer in super heterodyne receiver? Audumbar.
Amplification, ma'am, because convert IF into RF.
It converts RF into IF. So value of RF it is high and IF value it is less. So we cannot say it is amplification. उलट तो जास्त फ्रिक्वेन्सीला कमी मध्ये कन्वर्ट करतो आणि मिक्सर मध्ये काय होतं बेसिकली फंक्शन इट डज मल्टिप्लिकेशन ऑफ इनकमिंग सिग्नल अँड द लोकली जनरेटेड सिग्नल. Okay, so if you see, actually this is related with chapter number 4 mostly. मिक्सर मध्ये बघा काय होतं, मिक्सरला दोन इनपुट असतात. So first input to the mixer is this basic input signal and second input to the mixer it is local oscillator. ह्या तो multiplication करतो. Okay, so answer for this question it is multiplication of incoming signal and the local generated carrier. That is the function of frequency mixer. Then example of continuous wave analog modulation is, so here C is the correct answer, multiplication of incoming signal and locally generated carrier. Then next example of continuous wave analog modulation is analog modulation's example PCM, delta modulation, amplitude modulation and pulse amplitude modulation. So what is the example of this continuous wave analog modulation? PCM आहे का analog modulation चे example? Analog modulation म्हणजे काय, कॅरियर सिग्नल आणि मॉड्युलेटिंग सिग्नल दोन्हीही अॅनालॉग फॉर्म मध्ये पाहिजेत. दॅट इज द मिनिंग ऑफ द अॅनालॉग मॉड्युलेशन. सो PCM is not the example of analog modulation. Then delta modulation is not example of analog modulation. AM आहे का analog modulation चे example? analog modulation मध्ये दोन्ही सिग्नल कुठल्या फॉर्म मध्ये असतात? मॉड्युलेटिंग सिग्नल, कॅरियर सिग्नल कुठल्या फॉर्म मध्ये असतात analog modulation मध्ये? Both the continuous form मध्ये or both are in the sine wave. AM is the example of continuous wave analog modulation. Pulse amplitude modulation मध्ये सुद्धा एक continuous form मध्ये असतो आणि एक digital form मध्ये असतो. Okay, so this AM is the example of continuous wave analog modulation. Okay, then the next question is interfrequency should be carefully chosen as IF ची व्हॅल्यू आपल्याला प्रॉपरली सिलेक्ट करावी. as high in poor selectivity, IF ची व्हॅल्यू जर खूप वाढली तर ती त्याच्यामुळे सर्किटची सिलेक्टिव्हिटी कमी होते. दॅट इज फर्स्ट ऑप्शन. सेकंड, हाय IF रिझल्ट्स इन प्रॉब्लेम्स इन ट्रॅकिंग ऑफ सिग्नल्स. जास्त IF ची व्हॅल्यू वाढली तरी सिग्नल ट्रॅकिंग मध्ये प्रॉब्लेम होतात. देन इमेज फ्रिक्वेन्सी रिजेक्शन बिकम्स पुअर ॲट लो इंटरमिडिएट फ्रिक्वेन्सी. लो इंटरमिडिएट फ्रिक्वेन्सीला इमेज फ्रिक्वेन्सी रिजेक्शन पुअर असतं. अँड डी इट इज ऑल ऑफ अबव. सो द आन्सर फॉर दिस क्वेश्चन इट इज ऑल ऑफ अबव बिकॉज ऑल दिस केसेस आर ट्रू. IF ची व्हॅल्यू वाढली की सिलेक्टिव्हिटी कमी होते. IF ची व्हॅल्यू वाढली की सिग्नल ट्रॅकिंग मध्ये प्रॉब्लेम होतो. IF ची व्हॅल्यू कमी असेल तर इमेज फ्रिक्वेन्सी रिजेक्शन रेशोची व्हॅल्यू कमी होते. ओके, सो these all are the correct. That's why the answer it is all of above. Then next question is selectivity of the receiver. Means what? Selectivity changes with incoming signal frequency is poorer at high frequency is the rejection of adjacent channel at the receiver and all of above. So here the option C is correct, that selectivity means it is rejection of the adjacent channel at the receiver. जी आपल्याला व्हॅल्यू पाहिजे आहे फ्रिक्वेन्सीची तीच व्हॅल्यू सिलेक्ट करणे and to reject the another value that is called as the selectivity. Okay, so here the C option is correct. Then next, the factors that determine the sensitivity of super heterodyne receiver are. Super heterodyne receiver ची sensitivity कशावरून determine होते? That is asked here. So option A is gain of IF amplifier, B is noise figure of the receiver, C is gain of RF amplifier, and D it is all of above. So the factors that determine the sensitivity of super heterodyne receiver are all of above. So these all factors are deciding the sensitivity of super heterodyne receiver. Okay, so these are the correct. This is the correct option. IF amplifier चा gain change झाला की sensitivity change होते. Noise figure change झाले receiver ची की sensitivity change होते. RF amplifier चा gain change झाला तरी sensitivity receiver ची कमी होते. Okay, so this is all of above is the correct answer for this. Then next, frequency components of AM wave are कुठले कुठले carrier frequency with amplitude A, upper sideband omega C plus omega M having amplitude MA/2, lower sideband omega C minus omega M having amplitude as MA/2, and all of above. So what will be the answer for this? कुठले component आहेत AM मध्ये? Carrier आहे, upper sideband आहे, lower sideband आहे. So answer it is all of above. Then next question, examples of low level modulation are. Low level modulation चे examples: square law modulation, switching modulation, frequency discrimination modulation, both A and B. So both A and B is the correct option. Square law diode modulation आणि switching modulation हे low level modulation चे types आहेत. Okay, so these are the MCQs from chapter number 5. Apart from that, whatever are the additional MCQs, so I will just show you that additional MCQs from chapter number 3 and 4. Generally FM बद्दलचे आहेत आणि AM बद्दलचे आहेत. Okay, so that I have shared for A division students actually. So that there is link of that MCQ. I will share with you in your study material also as additional MCQs. Okay, so just a minute, I will show. See, multiple choice questions on amplitude modulation. Here are answers also. Amplitude modulation means what? With answers they have given the MCQs. Okay. काही काही एक्स्ट्रा पण असतील जे आपल्या सिलेबस मध्ये नाही आहेत ते पॉइंट्स तुम्ही कन्सिडर करू नका. फॉर एक्झाम्पल, इन AM डिमॉड्युलेशन कंडिशन विच लोड रेजिस्टर मस्ट सॅटिस्फाय, हे इक्वेशन वगैरे आपले झालेले नाही. ओके, सो दिस थिंग्स यू डोंट कन्सिडर. If we get lectures, I will discuss this MCQs. Otherwise, you can just study it by your own. Okay, so here we are completing with the syllabus. So total 5 chapters we have seen in analog communication. First one was introduction. Basic concepts सगळे बघितलेत आपण त्या chapter मध्ये. Second chapter was, what was the second chapter? Yes, tell. What was the second chapter?
Noise.
Noise. So in that chapter we have seen noise different types, त्याचे parameters, त्याचे derivation, noise figure derivation we have seen. We have solved the numericals based on that. That are the contents in second chapter. And third chapter is AM transmission. So we have seen how to generate AM signal, how to generate and transmit the AM signal, basic AM derivation, power calculations in AM, DSBSC, SSBSC, VSB. That points we have seen in the AM transmission. Then AM reception मध्ये आपण सगळं AM receiver चा स्टडी केला. AM receiver कसा वर्क होतो, त्याचे वेगवेगळे टाइप, वेगवेगळे बेसिक टाइप्स काय आहेत, how we can see the performance characteristics of AM. All that points we have seen in this AM receiver. And then chapter number 5 we have seen the FM transmission and reception. So mathematical analysis of FM. Actually here PM is not expected. FM, frequency spectrum, modulation index, bandwidth requirement, all that points we have seen in this chapter number 5. आणि हा जो 6वा होता pulse analog modulation, हा तुमचा आता रिड्यूस झालेला आहे तुमच्या सिलेबस मध्ये. Okay, so here we have completed the syllabus of analog communication. Okay, so do you want to discuss anything, or if there is any specific requirements from your side that you can tell me? Right now you can tell, or you can make phone call anytime and you can ask me if you have any doubts. Okay. Yes, if anything you have to tell, please discuss for next 2 minutes. आता ISC चा पॅटर्न सेम असणार आहे आणि ISC मध्ये मी सांगितलं ॲज इट इज कॉपी पेस्ट करून देऊ नका. At least something you try to write in your own words. And then you write down the answer. When you are submitting the answer sheets for ISC, at least try to write something in your own words. Yes, anything you want to discuss? Audumbar, Megha, Aishwarya, Amruta, from boys side, Nikhil, Sandesh. Okay, if revision lectures will be there after ISC, you tell me what is your requirement so that accordingly I can plan. But as per my opinion, we should go for more discussion of MCQs. तुमचे ॲडिशनल MCQ मी तुमच्या शीटमध्ये पेस्ट करते, तिथे लिंक पेस्ट करते. ओके, ऑलरेडी हे असाइनमेंट क्वेश्चन MCQची तुमच्या स्टडी मटेरियलमध्ये प्रोव्हाइड केलेली आहे. यू वॉच ऑल द व्हिडिओज which we have recorded during lectures, आणि ॲडिशनली सुद्धा जे काही तुम्हाला व्हिडिओज वगैरे मिळतील ते तुम्ही तिथं बघा व्यवस्थित सगळ्या स्टडी मटेरियलमध्ये. ओके, स्टिल इफ यू हॅव एनी रिक्वायरमेंट you can call me, we can discuss on that. Okay, so we will stop here. So thank you for your listening for all the lectures. Responses are also good comparatively. Last la थोडे कमी आले answers. It's okay, that can be understood. Okay, so all the best for your exam, for your study, and if lectures will be there for revision, we will meet in that case. Okay, so thank you. We will stop here. Type your number in the chat box and you can leave.